Notes 30. And we're kind of going into a little bit of notes of Unit 8 a little bit because we've been doing application problems with unit analysis. I think that's the best way to do it. So we're covering Unit 6 and Unit 8 kind of at the same time. So we're killing two birds with one stone. But why would you want to kill a bird? Why would you want to kill two birds? Don't do that. All right. So anyways, yeah, don't. All right, here we go, guys. Here we go. So note 30, area under curves, and I put FTOC. Sometimes they call it FTC. Relax. It's the same thing. The O just stands for fundamental theorem of, and some people don't think the of is enough to put it for an acronym, so they just write FTC instead of FTOC. So yeah, so look, I want this area under this curve, and I notice that I have x squared here, and then I see a nice linear line. You can, if you want, do two separate integrals for that. So you can, if you want, go like this. You can go integral from 0 to 1 of what function? X squared, and then make sure to close it with the dx there, because it's like height times width. The dx is your width, and it's an infinite amount of them, plus integral from 1 to 2 of 2 minus x dx. And you can do that, but I feel like you're doing more work than necessary. What type of shape is this in black? Yeah, can't I just use area of a triangle formula for that? You can. We'll do both. Just so you can see that it checks out. All right, so then we learned the fundamental theorem of calculus, part 1, part 2. Part 2 is the one where you do antiderivative, evaluate at the top minus bottom. Not that it matters, but hopefully you know, I mean, it does matter. But, you know, the part 1, it just means you're taking a derivative of an integral, which you get the inside itself. And because you take a derivative of the integral and they cancel each other out, then that means if you don't take the derivative, it must be antiderivative. That's just a quick synopsis, really quick, non-official. All right, here we go. Antiderivative of x squared, what is it? X to the third over 3. You can also say 1/3. I heard some of you say 1/3. When I have two integrals like this, usually you want to put this in brackets and then put 0 to 1, so it's understood that that one is just for that. And then I have two terms here, plus, what's antiderivative of 2? 2x minus, what's antiderivative of x? Not everyone at the same time. X squared over 2, or half x squared, from 1 to 2, like that. See? And then I'm just going to do upper minus lower. So I'm going to go 1 to the third power over 3 minus 0 to the third power over 3. That's just doing upper minus lower. Plus, bracket, I'm doing upper minus lower. 2 times 2 minus 2 squared over 2 minus 2 times 1 minus 1 squared over 2. Chav, why are you showing so many detailed steps? Because I want you guys to see what's up. Nothing crazy? Okay. Let's see. I see this is 0 here, so I'm going to just zero it out. I see 1/3 plus, let's see what I get here. 2 times 2 is 4. 2 squared is 4, divided by 2 is 2. So that's that guy right there. Minus 2 minus a half. And I guess we could have done it even faster. So let's see. I know I'm going into this a little bit. That's fine. 1/3 plus, let's see, what do we got? 2 minus a half, that's 3/2. Finally, 1/3 plus 2 minus 1.5. That is just going to be a half. And then finally, let's see, times 2 over 2 times 3 over 3. And then we get 2 plus 3, which is 5 over 6. There's my area. How do we feel? Yeah. I think it would have been easier. I'm going to use a different color. I think it would have been easier. Like this part, you probably just have to do it like this one. But this one, did I have to do it this way? I could have also done what? You told me a little earlier. Area of a triangle. Let's see. The base is 1, the height is 1, so the area of that triangle is just a half. So I could have just gone with this 1/3 here, and I could have just gone, so I'm putting it right here. Look at this. And this is not to be confused with that, guys. 1/3 plus 1/2, and look, you get the same thing, 5/6. Cool or not cool? Cool. All right, number 2. Oh, ask me questions. Do we have any questions, guys? Hit me. Okay. So on this one here, they want the shaded region. Do you guys see that shaded region in blue? I don't know if it comes out on your paper. Oh, yeah, it does. Okay. So what you do, remember that the integrand gives you the area under the curve. So I don't want that this time. So what you do, find the area of that box. And then once you find the area of that box, I'm going to subtract the area under that curve. Does that make sense? So I go, let's see, this is a 2. That's my height of that box. And then the width of that box from 0, bless you, from 0 all the way to pi. That must be pi. Do you guys see that? Pi minus 0. So the area of this rectangular box is just 2 pi. So I'm going to write 2 pi. I'm going to put area of box. Area of box. Chavez, what box are you talking about? This box here in purple. That entire box. Cool or not cool? Now I'm going to subtract minus the integral from 0 all the way to pi of what curve? Perfect. Let's see if we can do this. I'm going to go slow. 2 pi, that's just this guy right there, minus, I'm going to open up a bracket. What's the antiderivative of 1? X. Let's see if you guys get this. What's the antiderivative of cosine? Not negative. Sine x. Chop, how do you check yourself? Check yourself before you record. Oh, that was dumb. Don't do that. If I take the derivative of x, it's 1. If I take the derivative of sine x, it's cosine x. So do you see 1 plus? So that's how you check yourself before you wreck yourself. I couldn't help myself, guys. Sorry. Yeah. They told you guys to say that in elementary, really? That's funny. All right. Ian's like, no, I didn't see that. Sorry, Ian. All right, here we go. I think it's from like an 80s rapper or a 90s rapper. I don't remember. I'll Google it later on. 2 pi minus antiderivative. Oh, I already did antiderivative. I'm going to do upper minus lower. So it's going to look like this. Pi plus sine of pi is 0 minus and then lower 0 plus and then sine of 0 is again 0. I know you don't have to show that much work. By Ice Cube? When did he release it? 2 pi minus pi. Example 3. The function f is shown to the right if g is a function defined by, so g is defined by this function. Determine what could be said about g of negative 5, g prime of negative 5, and g prime prime of negative 5. Okay, so g of negative 5, we're not going to be able to get a numeric value, but we'll be able to tell whether it's positive, negative, or 0. Is the integral from 5 all the way to negative 5 of f of t dt. Are we still okay? I look and I say, here's 5, and then I start looking at all this until I get to negative 5. And all you're doing is just looking at the graph. You're looking at it and you're like, is there more area above the x-axis or below the x-axis? It definitely looks like there's more area above. So is this integrand positive or negative? Look at the limits. Look at the limits. Where are you starting? And you're going all the way to negative 5. So it's going to be negative because you're counting backwards. Cool or not cool? Cool. And then I'm going to go, before I do g prime of negative 5, I'm going to take a derivative. So I'm going to write g prime of x. And then do we notice, check this out. Focus, guys. Do you see an x at the top as the top limit? Do you see a constant in the bottom? So I can say that g prime of x is the same as f of x. That's the fundamental theorem of calculus part 1 that we did last week on Friday. Cool or not cool? So this graph that you're looking at, even though it's even though it says f, this is also g prime. So you're looking at the derivative. Cool or not cool? All right. So now I'm going to write g prime of, was it negative 5? G prime of negative 5 is the same as f of negative 5. So that I can tell what the value is. I go right to it, and I can see that it is negative 2. So that's what g prime of negative 5 is. Cool or not cool? All right. Next, g prime prime of x is equal to f prime, the derivative of f, because they're related. Are we still okay? All right, so I'm looking at this graph, and I can tell that looks like, to me, a horizontal tangent. Do you guys see that? So g prime prime, which equals f prime of x, so I'm going to write it here in the next line because I'm going to fill in the x. G prime prime of negative 5 is nothing more than f prime of negative 5, which is 0. Sometimes they ask you to put them in order, sometimes they don't, from smallest to greatest, and there it is. How do we feel? Thanks. She has a very unique thanks. Yeah, you went thanks. All right, here we go. Here we go. Okay, I'll stop. Example 4. Let h of x equal integral from 0 to x of f of t dt, where f is a continuous function with domain 0 to 12, graph to the right. I fixed it from the last notes. I made another one. So this one doesn't have the issues that the other one had. Find h of 0. It's pretty much the same question. I just changed the graph. All right, h of 0. So h of 0 equals integral from 0 to x, 0 to 0, because that's what I put in. Wherever there's an x, you put a 0 there, of f of t dt. Have you moved? So this is going to equal 0. Cool or not cool? Cool. What intervals is h increasing? Explain. H is increasing wherever h prime is positive. So I do fundamental theorem of calculus. This is h of x. So I'm going to go h prime of x is equal to f of x. So what you're looking at here is h prime. Oh, let me write capital H because that's how it's defined. Capital H equals f. Cool or not cool? So where is h increasing? From what to what? From 0 all the way to 6. H is increasing on the interval bracket 0 comma 6, since h prime, which equals f, is positive on, you can put a bracket on 0 because it is positive right at 0, but at 6 put a parenthesis. Boop. You could also say, as long as you don't say as long as you don't say anything wrong, you could have also said h prime of x equals f of x, which is greater than or equal to 0, and then you don't have to worry about the brackets. You can put brackets on all of them. Oh man. H prime. I think we'd still be fine, but you should always write the letter that they use. Cool or not cool? Cool. All right. What intervals is the graph of h concave up? Well, you can either say where h prime prime is positive, which is the same thing as saying, you always want to use the graph they give you, which is the same thing as saying where h prime is increasing. So here's what I'm going to write. I'm going to write h is concave up on the, and this you want to use parentheses, on the interval. Let's see, we just have one interval. From what to what? It looks like that is 9 all the way to 12. So that use parentheses. 9 comma to 12, since h prime, which equals f, is increasing on this specific interval. And there it is. How do we feel? Okay. Is h12 positive or negative? So let's see what h12 is. h12 is the integral from 0 to 12 of f of t dt. So let's look at this graph and tell me, is there more area above the x-axis or below the x-axis? Above, because there's more area above the x-axis. This h of 12 is positive. That's how you say positive. Cool or not cool? Cool. All right. Now I want to know where h has a maximum. You have a maximum whenever the derivative changes from what to what? Positive to negative. So this is my derivative of h prime. So I'm looking at this graph. Where do I change from positive to negative? Right at 6. So h has a maximum. We don't know the y value because they don't tell us. They don't tell us an initial condition, so we just know the x value where it has a max. H has a maximum at x equals 6, since, I wanted to say 6 and since at the same time, funny. Since h prime changes from what? Perfect. Positive to negative at x equals 6. There we go. Yes, miss. Yeah. Yeah. Because that means, it does say explain. There's more area above the x-axis than below. There is more, thank you, Espinosa. Above the x-axis than below. I do not have my A game today, that's for sure. Here we go. Example 5. This time, this is something with position, velocity, acceleration. The position at time t, and it's in seconds, of a particle is moving along a coordinate axis s of t, where this integral stands for the position. So, no, look, all it means is that this stands for the position in meters. I'm in some position. That's position. Nothing crazy. Use the graph to the right to answer the following questions. Give a reason for your answers. What is the particle's velocity at t equals 5? Okay, how do I get velocity from position? Derivative. Do I have a variable of t on the upper limit? Yeah. Do I have a constant in the lower limit? Yeah, so I'm going to connect them together. So I'm going to write v of t is equal to s prime of t, which is nothing more than f of t. So this, what you're looking at, is velocity. You know what? So no one fights about what letter is it. I'm just going to write v equals f, which equals s prime. Are we cool? Nothing crazy, right? All right, here we go. My velocity at 5 is nothing more than f of 5, which is 2. Done. Done, that's it. This is my velocity graph. Cool or not cool? Okay. Letter B. Is the acceleration of the particle at time t equals 5 positive or negative? How do I get acceleration from velocity? Derivative. Is the derivative of velocity, this is my velocity graph, at 5 positive or negative? Negative, yeah, why? Because it's going down. You could also say because if you draw a tangent line, that tangent line has a negative slope. All is good. So I'm going to write a of 5 is equal to v prime of 5, which is negative. You can put in parentheses negative slope. V has negative slope at t equals 5. There's your explanation for when you see this. How do we feel? All right. Check it out. Check it out. You're going to love this. What is the particle's position at t equals 3? Isn't this my graph for position? So can't I just go s of 3 and see where I'm at? S of 3 equals the integral from 0 to 3 of f of x dx. What does this mean, that integral from 0 to 3? That I got to find what? The area under this curve. Is this a geometric shape that I can find easily? Yes. So let's see. The base is 3. The height is 3. And because it's a triangle, I can divide this by 2. So 9 over 2. You can leave it as 9 over 2 meters. Or the meter mark or whatever. Yes, miss. When I integrate, this is f of x dx. But you're just finding area under the curve. It doesn't matter what letter. Remember, we called it a dummy variable, so it doesn't matter if you were to write a t here. I would probably be like, well, that kind of looks like an x. I would tilt my head a little bit, and I'd be like, it looks like an x to me. In physics, they make a big deal about it. In calculus, they don't make a big deal about it. I'm gonna put it back to x. Cool or not cool? Espinosa, you're okay? Okay. At what time during the first 9 seconds does f have its largest value? Does s? Okay, here we go. They want to know, when is s the biggest? Give me a t value when s is the biggest. Not 4. Yeah, at 6. Why? Okay, yeah. We're starting to...
You know?
Yes, I do. Here's what Alvarez said. Alvarez said at 6 because that is where the derivative is changing from positive to negative. You can also think of, let's put some context into this. Think about it, guys. Be smart. Isn't this graph the velocity graph? So, and remember, s of t just my position. So I start at 0 because if I integrate from 0 to 0, you haven't moved. Now look, moving right, 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 bam. I've been moving right all this time. And then after 6 seconds, you start moving left, moving left, moving left, moving left, moving left, moving left, all the way until you get to 9 seconds. At t equals 6, that must be the furthest, the most right you'll ever be. Does that make sense? You could also see it as that's the only time where the velocity changes signs. The velocity changes from being positive to negative, so you're moving right the whole time until you hit 6 seconds. At 6 seconds, that's the rightmost value of your position. And then after 6 seconds, between 6 and 9, you start moving left. You're not moving right anymore, so that's the biggest position you'll ever be. Does that make sense, guys? Okay, so I'm going to write that down. S has its largest value, so S has its largest value. That means the same thing as most right, I guess. But I don't think I would use most right or the rightmost value. No, you don't have to even write this part. Right, this is just for good notes. Rightmost value. S has its largest value at t equals 6 seconds, since this is the only location. This is the only, I'm going to underline only twice, location where velocity changes from positive to negative on this specific interval, or on, did they tell me anything about my interval? On the interval, 0,9, period. And I put brackets on the 0 and the 9. How do we, why did they what? Choose S?
No, because my S's and my 5s look alike sometimes.
I'm sorry, miss. So do mine. No, my G's and my 6s look a lot sometimes. Yeah. All right. Does all this, the capital G, yeah. No. I think I even heard you laugh or giggle at my lowercase g possibility. This guy right here. Okay, I'll stop. Okay. Approximately, when is the acceleration 0? This is velocity. I know acceleration from velocity. I got to take the what? Derivative. So I look for where I have horizontal tangents. Where do I have horizontal tangents? It looks like right at 4, and it looks again right at 7. So that's what I'm going to say. Acceleration is 0 at t equals 4 and t equals 7. And I'm going to put in parentheses. Looks, all right, it doesn't look, it is. Horizontal tangents. Horizontal tangents at those t-values on velocity graph, on velocity time graph. Perfect. Ask me again. We're good? For sure. For sure, for sure. Okay. When is the particle moving toward the origin? When is the particle moving away from the origin? Let's do the away one first. I start at the origin because at time 0, you are at 0. And you're moving away from the origin all the way until I hit what t-value? Not 4, but 6. Because you keep at 4, that's just that's just the maximum velocity, but I still keep moving to the right all the way until you hit 6 seconds. So I'm going to say moving away from origin from t equals 0 to t equals 6, period. And this time I did it instead of inner rotation, I just said from this time to this time. And then I'm moving toward the origin from what time? Yeah, moving toward the origin from t equals 6 to t equals 9. Full credit. Later on, we're going to talk about where we are at. Right now, we're rookies, so we're not going to talk about positions and all that good stuff just yet. We just know that this area is definitely bigger than this area, so I'm far enough to the right that I do not cross the origin. If this were to be like continue to be negative, eventually you would hit the origin and then start going away from it again, and that would complicate things. But right now, we're doing it simple, and it would complicate things, but it's not complicated. We'll talk about that when we get to that stage. On which side of the origin does the particle lie at t equals 9? Well, is there more area above the x-axis or below the x-axis? Above. So are you from to the right of the origin or to the left? To the right. So I'm going to write particle. Does it say on which side of the origin does the particle? Yeah. Particle. Oh, ask me. Yeah. Yes, good question. So the question is, what do you mean top and bottom? Okay, you see all this area beneath the x-axis, or beneath the x-axis, beneath the curve? There's more of it that is positive. So that means I went a lot more to the right than I went to the left. Because this area under the curve, whatever the area under, or whatever this area is, it's negative. But whatever that area is, that's how much you move to the left. Right, well, velocity is positive, so if velocity is positive, you move to the right. And then if velocity is negative, you move to the left. So you're to the right of the origin. Is that making sense or no? For sure. For sure, for sure. You're just telling me that. All right, tell me. Tell me what is this? How do I know I'm in the right, to the right of the origin?
Shaded area, area under the curve.
But above the x-axis, right? Because this area is bigger than the negative area. Okay. All right. Particle is to that little letter being blue bother you guys? Particle is to the right of the origin since, and I'm gonna use fancy symbols. And not fancy, but since area from 0 to 6 of f of x dx is greater than area from 6 to 9. And notice I'm putting absolute value. Why did I put absolute value from 6 to 9? Yeah, guys, if I were to just put the integral from 6 to 9 without the absolute value, this would still be bigger no matter what, even if the magnitude of the negative area was larger, because it's below the x-axis and you're going to get a negative number. So I put an absolute value, and is this math, like, does the context make sense?
Yes.
So does this check out? That's full credit. Does that make sense?
Would like this whole thing would still be correct?
Say it again.
Like, would the statement still be correct? It said like T equals 6 instead of 2 equals 9.
Where?
Okay, I see what you're like. Like it doesn't matter where, but because this is greater than
Okay, hold on. Okay, I'm struggling with that correlation.
Okay, tell me. It's because I don't understand the question.
So you know how it's asking for T equals 9, and we're saying that because it's to the right, because this area is greater.
Mhm.
So it doesn't matter which or T value, it would always be to the right because the area is greater.
The area between 0 and 6 has a larger magnitude than the area between 6 and 9.
So yeah, so
If you're
So-
on like this side, so you're like this far on the right. This is just attracting to the left. It's still on the side. You know what I mean?
oh, that's what it is.
So in my okay.
Yeah.
I don't know how to explain it, but
Yeah.
that's
So
It's like I'm like the hot with the area of say it's like 10 or something.
Yeah.
And so below it's like
Yeah. You're still on the right. You're just less on the right.
I get it, I see it.
yeah, maybe I should put numbers. Maybe that would have helped. You know what? I'm gonna do that next class. All right, guys. Here's what I'm trying to say. Look, guys, I'm just gonna make up numbers, and I'll fix it. I'll fix it tomorrow when we see each other again. I will make sure that I make one specifically with velocity and displacement. So the area under this was 30. Guys, focus. And the area under here was 10. Those are magnitudes. So remember, and I start at 0, position 0. At time t equals 6, I'm at position 30. So I'm 30 to the right of the origin. At time t equals 9, what position am I going to be at? At 20. At 20, because you went 30 to the right and then you went 10 to the left. I am still to the right of the origin. Does that make sense? So that's what this is trying to say, that the area, the magnitude from 0 to 6 is bigger than the magnitude area from 6 to 9. So I must be to the right.
That makes more sense.
Okay, so they're putting numbers.
Yeah,
Okay.
because then I can see it.
Okay. All right. Here we go. Last one, guys. Last one, and then we'll set you guys loose. So all this is practice with your calculator. So take out your calculator. Well, you did last time, but
Okay, that was also I think on me. I moved it from your desk.
all right, here we go. When you take your calculator, I recommend that you use, well, this one's not complicated, I don't think, but I recommend, oh look, lemicon, saying quit, a polar coordinate. All right, here's what I recommend you do. Let me change my mode back to regular mode. Mode, function. I guess for now you should get good at both of them. So let's just use it right now. Push math. Everyone push math. And then which button are you going to push, or what number? 9. Number 9. If you have the new operating system, it's on number 9. And then you have this symbol like this. My lower limit was what? 0. So I pushed 0. What was my upper limit? 10. In every time you have a fraction, every time, you should use either, I think you push alpha link and it'll do the fraction thingy, but if you don't like the alpha link, alpha y equals, and it'll also do it for you. See? You push enter. If you push the link right next to, yeah, alpha link will get you also this. Look, check it out. Alpha link, the new calculators will have the little fraction symbol there. If you don't like that, you can push alpha y equals, and look, there it is. Number 1. Oh, I already deleted my math 9. 0 to 10. Was it 0 to 10? All right, here we go. Alpha y equals, enter, and then let's see, what's my expression? 3 plus 2 sine x. 1 over 3 plus 2 sine x. 3 plus 2 sine x. Close. And then push x. Oh, delete. X. How long did it take? Yeah, it's working hard. Mine does it faster because it's a processing. Okay, you know what? It's probably good if you guys learn. I'll teach you guys something in a little bit because it might be good. Like, what if it never breaks and it keeps like running? So Yeah, enter on to enter to break it, and then on, enter to pause it, and then on to break it. It's code. All right. Here's what I recommend you do. I recommend you also practice putting it into y1. So alpha y equals enter, and then 1 over 3 plus 2 sine x. I believe that's what it was. And then you go to the home screen, second quit. And I'm going to try it again. Math 9, 0 to 10. And then just put your y1 in there. Alpha trace y1. Does everyone know how to get the y1 in there? Practice, guys, practice. Practice with your calculator. And you should get the same values. It will come in handy extreme. Practice, Espinosa, practice, miss. Oh, it's a theta. Push mode and turn it to function. You don't have a TI-84 like one of ours? I can lend you one. Did I ever lend you one? Well, ask for one, miss. I'll lend you one. Yes. Swing by after school. Okay. All right. Let's try this one. Oh, what was the answer, by the way? Okay.
No, it's
8019. Okay. Round or truncated, but 3 digits after the decimal always. Okay. Check it out. They tell us what f of 3 is. Are you guys okay? So how do I do this one? Here's how you do it. If they tell you that f of 3 is 4, look what they say. Let f of x equals, so I have a constant on the bottom, I have an x on the top, ln of 2 plus sine t dt. F of 3 is 4, then find f of 5. So here's what you do. If f of 3 equals 4, then force that 4 like this. F of x equals integral. I'm going to make my lower limit 3. And my upper limit still has to be an x because it says f of x there. ln of 2 plus sine t, and then close it with the dt. That ends that. And then on the outside, I put plus 4. Huh. Yeah, why? If I plug in a 3, look, guys, f of 3. Look, 3 to 3 of ln 2 plus sine t dt plus 4. All this that I'm circling is just what? 0. And what's 0 plus 4? So did I make this function give me f of 3 equals 4? Yeah. Yes. Now I can find any value I want. Any value. So now I'm going to go f of 5 equals integral from 3 to x of ln of 2 plus sine t, close it, dt plus 4. Take your calculator, and we're going to do exactly that. Oh, if you put a 5 there, then you no longer have an x as an upper limit. You have a what? A 5. Wherever there's an x, you put the number there. Sorry about that. So here we go. I'm just going to type in f of 5, 3 to 5, ln of that. So let's see if I can remember. I'm running on fumes here. Math 9. I already forgot. What was the limits? 3 to 5. Yeah, my short-term memory gets really bad when I get no sleep. ln 2 plus. It's still inside the parentheses? Sine x close, and then x here plus 4. I remember that.
Right there. We got a button. I was looking for it in the
4.555. Let's look for it. 4.555. That's the AP score you want. 5. Okay. One last calculator skill that I want you guys to do. So let's make the calculator work super hard. Let's see. Push math. We're going to freeze it. Let's see. What will make it work hard? Go to summation. We're going to do 10,000. That will do it. Number 0. Put x equals 1 to x equals, put 10,000. And let's give it a hard function.
My thing's almost dead.
Let's go x. Let's go ln. Okay, delete the x. Put ln of x squared. It should have a hard time with that. Okay, push enter. So we froze our calculator because it's going to take, well, mine will probably finish it before, but it might take a minute, it might take 2 minutes, it might take 3 minutes. But what if it's frozen forever? Well, it's not going to be frozen forever. Eventually it's going to stop executing. Hopefully it doesn't stop. All right, yeah, so how do you stop it? Mine did it, but yours is probably still running. Let me go ahead and do this again. Let me put 100,000. Did yours really get an error? You got a timeout error? Okay, so here it is. So do you see how it's just running and running and running? That little thing on the upper right-hand corner is like a little chip. It's supposed to be a little chip, and then do. Okay, how do you stop it? You push enter, and it's actually not a stop. You're actually pausing it. I don't see my little pause. Okay, well, sometimes you can see it when you're graphing. And then once you pause it, you push the on button. See? Now, if you try to push the on button immediately, I don't think it'll work. Watch. On. Oh, I guess it will. I guess it will work. Just pushing that. Well, there it is. Whenever yours gets stuck, just push on. If you're graphing, you're going to have to push the enter button and then on. Cool or not cool? Okay. Well, yeah, I learned something right now. I guess you don't have to push enter if it's on the home screen. Okay. That's it. So just we got a Delta assignment, and we're done, guys.